In this video, I will be explaining acid-base strength. So which acids are considered strong acids, and which bases are considered strong bases. So acid base strength. The first thing you should know about this is, do not get confused about the term strength here. It doesn't mean how deadly an acid or a base can be, but more like it means how strong of an electrolyte it is. So strong base and a strong acid will be a strong electrolyte. So it will ionize 100%. So let me show you how a strong base behaves, or how the reaction undergoes. So a strong base would be lithium hydroxide, and using our solubility rules, we say it's aqueous, and we write an arrow to, this will ionize 100%, so we'll get lithium ion, aqueous 2, plus the hydroxide ion, and it will be aqueous 2. And what you really have to be careful about is that, so you can write in there that it ionizes 100%. However, if you have a weak base, something like ammonia, NH3, we know it's aqueous, and we react it with water, that is a liquid, to form NH4 plus aqueous 2, and we get OH, the hydroxide ion, aqueous 2. And although it may seem very similar to what happens in a strong, let me identify H, strong, in a strong base or acid reaction, there is a key factor that you have to use, and that is that instead of writing this arrow as a normal arrow, you will use it as a large arrow and a little arrow. So when you write something like that, double arrows, one being smaller than the other one, it shows first, let me write another page, so double arrows show poor ionization, so that would represent a weak electrolyte or a weak acid or base. And second, that it favors the side that has the biggest arrow, so it usually is the unionized side, so it favors unionized side. So the reactants in this, let's do another example using a weak acid. I'm going to use hydrofluoric acid, and this is a very good example that tells you that weak acids can be really deadly. So don't get confused about how the word acid-base strength. Although it's a weak acid, it can melt your skin. So make sure you know that. We have that weak acid, and we react it with water too, or liquid, and we're going to do the same thing. So bigger arrow here than the small one here, and we get hydronium plus fluoride ion. They're aqueous too. And although they seem ionized, they're not totally ionized, and the process or the reaction favors this side, the reactant side. So it means that the unionized form will be more common and will be more stable. It won't ionize as much. That's why it's called weak. So make sure you understand the arrows. They will usually be on the reactant side, pointing at the reactant side, the bigger one. So yeah, whenever you see double arrows, they're usually weak or strong weaker acids or bases. So now let's talk more about strong bases and acids. So there are 7 strong acids. And these are HCl, HBr, HI, HClO3, HClO4, HNO3, and H2SO4. And well, these 7 strong acids will ionize 100% in water. So something like, let's go with nitric acid, HNO3, it's aqueous. We'll react it with water. And we'll write 1 single arrow to form hydronium and NO3 minus. And this ionizes 100%. One more thing, there are 2 terms you should know about acids. If something is a monoprotic acid, or a diprotic acid. So a monoprotic acid will donate 1 mole of hydrogen ion per mole of acid. So basically this is saying that it only has 1 hydrogen in its compound form. So something like our nitric acid, HNO3, or hydroiodic acid, and so on, using the 7. So there will be 6 monoprotic strong acids, and there is 1 diprotic acid, and so a diprotic acid donates 2 moles of hydrogen ion per mole of acid. So the H2SO4. So just by looking at the number of hydrogens each has, this one has 1, this one has 2, you can just tell the difference. Mono is 1, di means 2. Now we get to the strong bases. So, wrong color. Strong bases. There are more strong bases than there are strong acids. And let's write them. The first one is the one I use, lithium hydroxide. Then we have sodium hydroxide, potassium, rubidium hydroxide, cesium hydroxide. So our group 1A metals pretty much. Then we have some from group 2A. So calcium hydroxide, there's a 2 here. Strontium hydroxide and barium hydroxide. So if you remember the solubility rules that I talked about before, basically our strong bases are the elements that will always be soluble. So you remember that group 1A is soluble every time, and from calcium to barium in group 2A they will be soluble too. So the exceptions we have are what we call the strong bases. So one of the solubility rules said that hydroxides are usually insoluble except for those of group 1A, so it'll be this part, and from calcium to barium in group 2A, so this part. So if you remember the solubility rules, you will have no trouble remembering the strong bases and acids. So we have 7 strong acids and 8 strong bases. And remembering which is really essential for chemistry. So try and do your best.